Alright, and last but not least are covalent compounds, the easiest ones that we looked at today actually. These are made up of two or more nonmetals bonded together. They're bonded by the electrons being shared instead of being transferred. And the other ones, the cross and swap works because we're transferring electrons and there are charges due to those transfer of electrons. However, here we do not have charges because they're sharing instead of transferring. So that makes things a little bit more complicated, but also makes our lives a little bit easier. Okay, so with covalent compounds, because there are no charges, we have multiples of the same elements forming different compounds. CO, CO2, NO, N2O, N2O4, SO2, S2O3, etc. We can't cross and drop these because we don't have charges to determine which one of these are going to form. So that's what makes things more complicated. But due to that, Mr. Akins and I can't ask you to tell us what is sulfur and oxygen going to form. You can't do that. We don't know. That depends a lot on the reaction that's occurring to form that compound. So how do we name these guys? How do we do this? Well, we name them by naming the number of elements in each compound, or the number of each element in the compound. So the prefixes we use, 1 is mono. We don't ever use mono for the first element. We do always use it for the second if needed. 2 is di. It would be used for both elements as needed. 3 tri. 4 tetra. 5 penta. 6 hexa. 7 hepta. 8 octa. 9 nona, and 10 deca. Most of these are probably fairly familiar to you. But we've got to figure out how to use them. So let's look at the next one. When we're naming these, first and foremost, something to know, do not ever simplify these. We simplify ionic compounds. We do not, for any reason, simplify covalents. They are what they are. So N2O4 is N2O4. It is not the same thing as NO2. And that's again because these aren't charges. They're actual numeric values of what's being bonded together. Okay? For the first element, you are going to name, use its prefix if it needs it. If it's only 1, we don't use a prefix. If it's more than 1, we do use a prefix. And we use a prefix always for the second element, and we always change the second elements to IDE. We do not ever change the element's name for the first one, so keep that in mind. The first element's name is exactly what it is off the periodic table, except with a prefix if needed. The second element, we do always change the ending to IDE, and we use a prefix all the time. So let's look about how this works. C2O6. C is carbon, O is oxygen. The reason we know this is covalent is because they're both nonmetals. That kind of gives us that hint. 2 is di, so we use di here and we name the element, dicarbon. 6 is hexa, oxygen, we change the ending to oxide and we get hexaoxide. Some people do drop the double vowel and might just say hexoxide. It doesn't really matter, both are technically correct and it's kind of your preference and your teacher's preference as well. Okay, SCl4. There's only one sulfur, so we don't need a prefix here. We just name sulfur, so sulfur. 4 is tetra. Chlorine becomes chloride, so tetrachloride. Sulfur tetrachloride. Okay, so let's try some of these. We have P4S5. 4 is tetra. So we say tetra. We do not change the ending of the first one, so just phosphorus. Okay. 5 is penta. Sulfur becomes sulfide. Okay, so tetraphosphorus pentasulfide. Yeah, they sound a little bit weird, but that's how we name them. Se is selenium. We do not need a prefix because it is the first element, and there's only one of them. Fluorine is hexa. Fluoride, because there are 6 of them and we change the ending. Si2Br, di-silicon, and then hexa, because there's 6, bromide. And you get the basic gist. CH4 would be carbon tetrahydride, nitrogen trifluoride. Not too bad. Let's talk about how do we write these into compounds. Well, it's just as easy. Antimony is Sb. There's only one of them because there's no prefix. Tri is 3. Bromide is bromine. So we have SbBr3. Notice no cross and swap. I'm only writing exactly what the name tells me. Hexaboron tells me I need 6 borons, because it's hexa. Monosilicide tells me 1 silicone. Okay, chlorine dioxide. 1 chlorine, because there's no prefix. Oxide, 2. Dihydrogen means 2 hydrogens. Monooxide or monoxide means 1 oxygen. Hey, there's water. Dicarbon hexahydride. Dicarbon, 6 hydrogens. So, not too bad. Iodine pentafluoride would just be IF5. Oops. There we go. And phosphorus triiodide would be PI3. And typically we do keep the double I's, but just something to think about. All right, so that's naming covalent compounds. That's really all there is to it. What we will do next time, on the next video, we will just go through and identify all different types of compounds and how to name them. But for right now, that's it.